Let's get started here. We're going to start talking about area of a region between two curves. So the first two pictures here are something that we do already know. Okay, so when we find the integral from one part of a function to another part, it gives us the area. Okay, so no matter if it's concave up, concave down, or whatever. So these are the two examples of those. Now, if you want to find the area in between them, you have to take the top one, which is the bigger value, big minus little. Take the big one, subtract it by the little one, and that will give you the area in between. Okay? So, to find the area of this one right here, now this is just a function, so we're not going to integrate anything other than a function. So I'm integrating from what to what? 1 to 3 of f of x dx. That's it. We're just setting it up. You don't know what f of x is. Granted, you could probably figure it out if it told you it was a parabola. Well, I don't know. Maybe it's a... maybe if it's a sine graph. You don't know that. There could be more points going on over here that you don't know about. The middle one right here, how would I integrate this one to find the second area? You do. You just integrate from 1 to 3 of, this is g of x, so g of x dx. And now this is these two functions combined. Finding the area in between them, you're going to take the big, which one's big, and which one's little. So you're going to take the integral from 1 to 3 again, because that's what has the area, and do f of x minus g of x dx. It's always big minus little. Big minus little. So we're going to be doing this, and the reason I always say it's top minus bottom, because we might be integrating from left to right, rather than top and bottom. So I always just say bigger. Big minus little. Okay? So these are the steps to find the two curves. You would just sketch or draw the graphs, determine if you wanted to go the route of dx or dy. We'll talk about that when we get there. Find the boundaries or the intersection. Sometimes they give you the boundaries. Sometimes you need to find the intersection. And then you're going to set up the integral and then evaluate it. Okay? So let's do it. Dun, 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 dun. Okay, so for a lot of these, I'm just going to set it up and then give you the answer unless I think the integral is challenging. Okay? Just to save time. We don't need to go through and integrate everything step by step. We have done that at some point. So at this point moving forward, I'm trusting that you know how to integrate basic functions. We cool with that? Okay. So find the area of the region bounded by these graphs right here. It was x equals 0 and 1. So real quick, how do we graph x squared plus 2? We don't. It's a parabola that just got pushed up 2. So it starts here. Okay? And then negative x. That's a tough one. It's just... What's really nice here is it gives us our bounds. We sometimes have to find those. What are our x bounds? 0 and 1. So here is 0, and here is 1. So I'm going to shade this region right here. Okay. So integrating this, what are my bounds? 0 to 1. What's my big function? X squared plus 2. Minus, what's my little function? Negative x dx. So this would turn into x squared plus 2 plus x dx. Do I need to go through and integrate each of these individually and do this? Tell you what, it's on the notes if you want to practice it on your own. But I'll tell you the answer right now is 17/6. Okay. I don't want to be too insulting. I think it's insulting if I go through this one. Now, if you're insulted because I think it's insulting, you need to go to tutorials. Okay. Number 2. Find the area of the region bounded by the graphs 2 minus x squared and x. Let's go off our phones, please. That's insulting. What's different about this number 2 than it is with number 1? Okay, well, 1's going down. That's not what I was referring to. What did the first one give you that the second one didn't? Give us the bounds. We don't have the bounds. So we have to figure out the bounds. Okay? So it's going to help by drawing this. So let me go ahead and draw this. I'm going to start up here at 2, and it's a down parabola. It really helps if you know how to draw a down parabola. Like that. Okay? If you're totally lost on how I drew that, go to tutorials. And then x so here's my shaded region. What's my left bound? What's my right bound? Okay? There and it's there. That's graphically. If you had to solve this algebraically, all you would do is you would set f of x equal to g of x. So for this problem, you would do 2 minus x squared equals x, and you would just have to solve for it, and you get the bounds. Okay, what's my top function? What's my big one? 2 minus x squared. I put in these parentheses because I like to set it up nicely. Minus. A lot of times the AP will just ask you questions of set this up. Sometimes they don't even ask you for the answer. They'll say, hey, set this up. So this will be written as negative 2 to 1 of 2 minus x squared minus x dx. And you want to know the answer? Or you want me to work through it? It's not 23 over 6. It's actually kind of close. It's not over 6. Nothing even like gets over 6. It's actually 9/2. So again, you can try that on your own, send the notes. It's all worked out. You said, what again, over 6?
9 over 2. 23 over 6.
27 over 6. Close. Okay, so sometimes you have problems like this, where the big and the little change. Jason, off your phone. So this one, the big and the little change. Okay, so they drew it out for us. Very, very nice. A lot of times there'll be AP problems that for free responses, they'll draw it for you. They'll tell you what the functions are. You just got to do the rest from there. So for this one, I have 2 different regions. I have red. And how is there no blue over here? Someone took the blue. Oh, there's a baby blue. And there's a blue. Okay. So do you agree that I need to find the area of red? And I need to add it to blue. And that will give me my answer. Okay, so for red, let's set it up. What's my bounds for red? Negative 2 to 0. What's my bigger? Yeah, so it's nice to know which one's which. By the way, that one that has multiple maxes and mins, that's the cubic. The other one, just the one max or one minimum, would be the parabola. So it's going to be the 3x cubed minus x squared minus 10x. Okay. Minus, what's the little one? Negative x squared plus 2x dx plus, let's do blue. What are my bounds for blue? 0 to 2. What's my big one? Minus, what's my little? Very good, class. It's 3x cubed minus x squared minus 10x. You should be. Any questions how I set this up? Just have the big and the little change. Want me to tell you what the final answer is? Alright, Mason. That reduces down to what? It does reduce. Yeah, one of the numbers right. One of the digits right. 24. Alright, and there's really just, this is the last type of problem, and then I think we're going to go into the calculator stuff. Or it looks like there's a free response to the practice. Okay. Okay. Now this one's a little bit more kind of obvious how to, on what we should do for the first step, because these are x equals equations. Alright, if you were to, I'm going to go ahead and zoom in. Okay. Do you agree that back on this first problem right here, no matter what partition I drew, if I just drew a line from top minus bottom, blue would always have the same top, always have the same bottom? Just like if I drew for red, no matter what line I drew, vertical line, it would always have the same top and the same bottom. Is that the case for this one right here? Is it always going to have the same top and always have the same bottom? It's not. Okay, it's going to be different. So this top and bottom, oh, I drew too long. Oh boy, kids these days. Is different from this top and bottom. So this would require you to have two separate integrals. Okay? So I'm going to kind of go through and set this one up for you. So what's the bigger one for this one? The line. Okay? Which one's the line equation? Yeah, but this isn't y equal, so what is y equal? Well, let's call it 1 minus x so I can move that. Wait, no, x minus 1. Oh, boy. I hate this problem already. Y equals x minus 1. There we go. Okay, so you would integrate from... And if you don't want to write this down, you don't have to. You can just watch because I'll go over the quicker way to do it. You integrate from what to what? -1 to 2. And that would be from x minus 1 minus... Ruh-roh, I need to do what to this one? It's y squared equals 3 minus x. So y is equal to, there's a plus and a minus. 3 minus x. So this bottom one, is that the plus or the minus? It's the minus, because it's... Yeah. It's the minus. Because it's going to be negative. So it's going to be... plus, I would need to add this next little part. What's the bound for this next part? 2 to 3. What's the top bound? The positive of these, so it's going to be root 3 minus x minus, what's the lower bound? For this one. The negative. Yeah, the line's not in this one. In this little part right here, if I'm covering it up, in this little part, the line's not involved. It's the top part of the quadratic, bottom part of the quadratic. That's a lot of work, isn't it? Don't you wish there was an easier way? Easier way to set it up? There is. What if I drew green? Green partition. Ah, you can't tell it's green, but it's green. Too zoomed in. Hey, it's green. Deal with it. Okay. Okay, so let's do this partition. So if we're doing this partition, I have to do dy. So now I'm integrating with x equals equations. I need x equals equations. Luckily, the problem already gives them to me as x equals. Okay, so for my x equals, my bounds are going to be a little bit different. My bounds for when it's y equals is left bound, right bound. This is no longer left bound, right bound, but it is lower bound. Like physically, like the vertically lower and the vertically upper. What's my vertically lower? -2. What's my vertically higher? 1. What's my bigger function? Now, in this case, bigger would be to the right, because look at the numbers are getting bigger and bigger and bigger as we count to the right. So my bigger function is 3 minus y squared. That's bigger. Minus, what's the smaller one? Y plus 1. D nice. Which one do you think was easier? Gray or green? Much easier. Okay? You can always, like on your AP, it might ask you to set it up. Yeah, then you need to do it a certain way because you just look at multiple choice questions or answers. But on a free response, you can actually do it either way you want. Which one do you think is going to take you longer?
The first one.
Probably the first one. Okay, so just kind of be aware of that. I would set it up using green, and it would give me an answer of what, Mason?
16/3.
Close.
And still,
9.5.
people create
Nine halves.
If we could make up math, maybe we get like 9 halves. I think we should do it.
If I could make up the math,
No.
I don't think I can work backwards.
If we could somehow find a way to get to 9 halves that's for like every answer, I think we deserve 85.
But
that still
doing-
requires some knowledge of math.
But you can do incorrect math. You have to do incorrect math to get to that. Here is an example.
Actually, you could do the right math.
Here is the example from a free response. There would be more parts to this. We just haven't learned those extra parts yet. So let f of x be a parabola. G of x is a it's a trig function. Let R be the region bounded by the graphs. F and G as shown in the figure. This is very common. They like to do this. They like to just show graphs. They're not telling which one's which. You got to figure that one out. This one, they give you the intersection. They don't always give you that intersection. I'm just warning you. They don't always give you that intersection. So sometimes you need to find that intersection. This is just very common. So first off, let's go ahead and write an equation, the tangent line at 2. This is going back to August. So how do we do this? Or how do we write equation line tangent? We need to find the slope. So how do we find the slope of f? So we need f prime. What is f prime? Hopefully you didn't forget how to do... I heard it. What is it, Mason?
4x minus 6.
And what's the slope at 2? 9/2?
No, it's 2.
It actually is 2. I have my x value. What's my y value? It's nice they kind of just gave it to you right there, but you could always just plug it back in the check. So I will get y equals 0. So my equation is y minus 0. Do I need that? Okay, fine, whatever. Equals 2 x minus 2. Full credit.
Shut up. I did it wrong. I don't want to talk about it. Yeah, it has PG100.
Okay, let's find the area of R. So you need to know what the bigger function is.
The bigger one's the cosine.
How do you know that?
I just guessed. That sounds about right.
Is this an up or a down parabola?
Up. It's up.
Bottom one's the little one. It's F because it's an up parabola. Okay, and cosine didn't get shifted at all. Remember how you had to like sketch cosine? You're like, when am I ever going to use this again? Well, right now we didn't shift cosine. Cosine starts at whatever the amplitude is. So that's what the order is. So let's go ahead and set it up now. So what's my bounds? 0 to 2. Again, I'm going to just draw this line. It's much easier to integrate vertically because it has the same big, it has the same little every single time. So 0 to 2 of... What's the top function again? Minus do you want me to finish this one completely or just tell you the answer? You think you can figure it out? So you would do the U sub on the first one. Probably should work on it.
Yes.
Yeah, I
Because
feel
you said I didn't see where you...
Okay, so for this first one right here, we can't just integrate cosine because I have this little guy right here. Okay, so what I'm going to do is I'm going to split this up into two different problems. The right-hand side, not a problem. So on this side, I said you have to do U sub because you have this 1/4 pi in front of the x. So what is U going to equal? 1/4 pi, you all said?
Yeah.
1/4 pi x. Du is equal to 1/4 pi dx. So 4 over pi du is equal to dx. What else do I need to change? The bounds. So if I plug in a 0, what do I get? That's nice. 0. If I plug in a 2, oh no, trig. Oh no. I'm saying oh no because my confidence in you in this is not good. Hey, prove me wrong.
No, I can't.
So plug in a 2, you're going to get, so pi over 2. No, it's not my confidence you got that. It's my confidence of when we had to go plug it back in. That's my confidence going to be raveled.
Now I do it. I just didn't understand.
Okay. So this is 4 over pi times 4, integrating from 0 to pi over 2 of cosine of u du. Changes to, so when I do this, first off, that 4 times 4 is, so it's 16 over pi. Antiderivative of cosine is sine of u evaluate it from. So sine of pi over 2. Sine of pi over 2 is going to be... Oh, okay. Good for you. See? Because of spite, you're all doing better now. Yes. So it's going to be 1 minus 0, you agree, which is just?
1.
So the first part, 16 over pi? What's that? Okay, on this side right here, I'm going to do this in red so you can see the difference. I'll do it in blue so it's see the different colors as we're going through this. Antiderivative of 2x squared is going to be 2/3 x cubed minus 3x squared plus, evaluate it from 0 to 2. So we're going to get 2/3 times 2 cubed minus 3 times 2 squared plus 4 times 2 minus, what happens when I plug in a 0 into all those? They're all going to go away. So do I need to write anything other than just a 0? Okay, that's just for your sake. If I want to go through and write it, I could, but everything's going to get zeroed out. Let's do some hardcore math here. Here we go. 9/2. 4/3? It does become 4/3. Did you do it ahead of time?
I did.
Oh, very good. So what, 16/3 minus, that turns out to be 12 total?
Oh, negative 4.
So 12 plus 8 minus 12 plus 8. So that becomes, you said, 4/3. Guess what? I like it. It's free response. You're done.
That's it?
That's it. It's not 9/2. There's a pi in the answer. Not 9/2. Okay, let's get out our handy dandy calculators. I'm going to show you how to do this in the calculator. So finish writing that down and get to the calculator. I like you again showing you new things in the calculator you've never known before. I got the wrong one. It's like the claw machine, you know, they're like, alright, I'm going to get that, whatever it is. Oh, I'll take it.
Exactly. You don't need a calculator. We have never used a calculator.
Okay. You need to be sharp in this usage of the calculator, so if you need a reminder how to use the calculator, you know, we're about 28 minutes into this video, so if you ever want to see this again for the calculator, please do. So whenever you need to find the area of these two regions, my first suggestion, here, let me turn off the light, I think it makes it better.
Oh, I can see the green now.
A little bit better. Oh, hey look, it's green.
Oh, cool.
Okay. What I'm going to do for this one is I'm going to plug in both functions into my y equals. So let's go ahead and do that. So negative x squared plus 4x plus 1. That's y1. And what's really nice about these calculators is they're color-coded, so you can tell which one's which. And for the next one, it's going to be e to the 1/2 x minus 2. Are we ready for me to graph these? I'm just going to do zoom 6 because that would be the standard. And we'll just figure it out from there if that's a good enough picture or not. Ooh. I think this picture will be good. Okay, so if I was allowed to shade in this computer, calculator, I'll just do it anyway. It'd be like this right here, right?
Yo, did you just shade on the calendar?
I call it a computer, so it wipes right off, okay? Jeez. Okay, let's do a darker one and you can see it.
I don't know what date it is now. Come on, man.
It comes right off, people, okay?
That doesn't make it go better.
I don't believe it.
Don't use pen.
Well, what if I did?
It's fine.
It'll come right up, right?
Oh my gosh, you just skipped that. I am a little genius. Alright, you're gonna go to second trace.
So you don't react about anything I do in class until I start drawing on the calculator. That's where we draw the line.
Trace is second. Coach, I know what to do. You're gonna go second trace 7.
Okay.
Parents pay taxes on that
Second trace
calculator.
7.
Okay, you need to find the intersections, because what you're going to end up doing here is, quiet please,
Second trace 5.
you're going to integrate. I don't know the bounds yet, but which one's the top function? F of x. Since using the calculator, you can just use f of x. You do not need to write it out because you have the calculator. Save yourself time. It's f of x minus g of x dx. I do not know the bounds. This is what I need to do, is find the bounds. And how do I do that? Hit second trace, and you're going to find the intersection. How many intersections are there? It's 2. Just get the little guy near those two, one of the 2 intersections, and just hit enter 3 times. It's going to ask you 3 questions. Okay, we need to use this exact answer. So you get this number. Okay? Quit. Go home. Hit second, quit. Type in the x and hit enter, and guess what happens? The x value just appeared. Did we not know this?
You gotta be
No,
kidding.
that's cheating.
There's no way. Oh my gosh.
Again? Okay.
No, don't do it again.
Now my brain hurts.
So again, from the graph, you just second trace, intersect, go to wherever it is, answer the 3 questions. It's going to tell you what x is equal to. Go to the home screen, type in x, and kablamo, it pops up. Now, I'm going to find a different x in a second. So, I want to save this. If you hit store, store is this STO, store, not L1. Hit alpha, the green button, A. And now every time you press alpha A, that number will pop up. Bam. Okay. So, I'm integrating from A is my bottom bound. You might want to tell the grader what A is. What is A? Negative 0.493. I put 3 dots afterwards because that means there's more. But I don't feel like writing more. You want to try doing the second one on your own? So try doing the second one on your own. See if you can store it as the letter. Do you have to store it as B? Could you do C, D, E, F, G? It has to be A and it has to be B. So, second, I'm going to just do it real quick. Okay. So, X stored as B. So, I'm going to go from A to B. And B is equal to 3.319 dot 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 dot. Here is the beauty of the calculator. Please note that y1 is my f of x. You can go through and type in exactly what you have here, or pretty darn close to it. So I'm going to alpha f2 integrate. I don't know why those are crossed out. Oh, this must be in... It's in test mode. Who the heck would put this in test mode? Who put it in test mode? You know what you have to do to get this out of test mode?
You kill it.
You need to link it to another calculator in order to get it out. It's annoying. Okay, so we're going to go from A to B. What was my f of x? I typed it in already.
Wait. Never mind, that's right.
Y1, so hit alpha F4, pull up Y1, minus Hit alpha F4. Alright, in pre-calculus, I'm going to start preaching for this. We just need like a whole calculator unit, just on how to do basic calculator things, how to recall stuff.
Wait, don't start commenting because we're like absolutely like bad to use it.
No, you need to know how to use it. So you hit enter and kablamo!
Wait, don't say anything. Oh, I won't go to a fraction. I want to go to a fraction. The answer is 11.804. Okay, now put O negative.
So how much math did I show on the paper?
0.
None. But I had to tell the grader what I was doing. I had to set it up, I had to show the bounds, and I had to tell you what those bounds were. Okay? This is all you need to do. This gives you full credit. If you do not have the setup or do not have what these bounds are, you're not getting full credit. Okay? If you just write 11.804, sorry, actually I give you 0 credit because you have to prove that answer somehow. Okay? If you forget to write these bounds, well then there's probably a point that I take off for the bounds. Okay, so make sure you show these bounds. Some people, instead of doing this, by some people I mean me, sometimes I'll just do this. I'll just go, oh, from like negative 0.493 dot 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 to 3.319 dot 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 f of x. Is this acceptable? Yeah, that's totally fine. If you don't want it, just tell me that you put them in A and B or whatever. Alright. Neelish, do you understand this entire lesson? Of course not. Neelish, I'll see you in a month. I can answer that in the video. Alright, and then they have another example. I'm not going to insult you. You can try that one on your own if you want at some point and check your answer. It's on the, just key. Okay, because I want you to start practicing. I do have a worksheet for you to practice on, so. That's it.